Hello, everybody. So we are about ready to start the next session. So please find a seat or hang out in the bar. That's okay. So basically, this pitch session is going to be about 8 different small pitches that will introduce the side of the Center Transport DTU, which we call innovation. I am Allan Larsen. I'm an associate professor here at DTU, and I'm going to head this innovation string of the Transport DTU Center. So I will now try to organize this pitch session by calling up in order, according to the program, these 8 pitch sessions. So please first welcome Henrik Sylvan, head of the Railtech Center, who's going to be talking about the Railtech DTU.
Thank you. Yeah, at DTU, we are actually engineering the future train. And to do that, we need a lot of competences and discipline to work together. So actually, we are starting in sort of scope, not only with the transport DTU, but also what it takes to build the future trains. And the Railtech Center is a new entity at DTU, and there we are trying to coordinate and facilitate processes in the research area and the education line for the study line for railway as well. Building the train actually is more in track works, infrastructure. Like, for instance, the photonics, that is the signaling communication part, which is maybe outside the picture here. We have the electrical engineering, of course. We have civil engineering, of course, tunnel bridges, even the coming track bed, which maybe is bitumen, blacktop, underneath the track for the future. It could be wind energy, researching in a strong metallurgical area, which is from wind energy, the forces in the wind. It could be used for making switches, which is a soft or weak point in the railway infrastructure. So the competences from that area too can come into the railway. Mechanics, of course, the wheel track dynamics, having a smooth ride in the train. There's a lot of competences there. So all these departments at DTU, we are trying to get the whole perspective drawn up and work together across DTU. So the Railtech Center is not only about timetabling, simulation, capacity analysis within the transport, the dedicated transport field, but much more in the technical part. So I think today we will start very much in scope, that transport is much more than people coming around and mobility, environment issue, and so on, but it is very much also the technical disciplines. Is that 180 seconds?
Thank you very much to Henrik. Please give him a hand. So next up is Mette Sanne, from the Maritime DTU Center. Please, Mette Sanne.
Thank you. Does it work? Okay. Can you hear me? Nope, doesn't work. So I will talk in this one instead. As Allan said, my name is Mette, and I'm the new head of Maritime DTU as of 1st of May this year. So the center was established 2 years ago, and we have approximately 100 researchers that has interest within the maritime field at DTU. And right now we also have approximately 35 ongoing projects, including PhD projects with maritime interest at DTU. The idea of the center is that it should strengthen the research, the innovation, and also the research-based consultancy within the maritime field at DTU. And as the industry plays a very central role for the center and its activities, DTU will provide the stakeholders of the Blue Denmark with access to state-of-the-art research and knowledge, and also resources for joint problem solving. The idea of the center is to act as one point of contact between DTU and the industry, so that there's an easy entrance to DTU for the industry to get in contact with the university, and also so that we can collaborate closer together in solving the technical problems of tomorrow. The students are also key to the university, of course, and the university education is based on research, so education and research go hand in hand, and it's important for us to educate and attract capable and talented students to the maritime field to study across the DTU departments and the engineering disciplines. It's also important for us to help them open their eyes to see that there are a lot of interesting areas they can actually work within in the maritime area, both in research but also in the industry. And then it's also important for us to help educate candidates that are attractive for the industry to actually employ or to hire in their companies. There's a lot of different departments also, as you could see before with the rail tech. We also have a lot of different departments activated and engaged in maritime research at DTU. So we have a lot of cross-functional collaboration, both within the research and education, but it's also important that we kind of support these synergies within the maritime field. And also that we help create a better foundation for cooperation between the DTU departments that are interested in maritime research, also with other universities in Denmark and internationally. This also means that it may be necessary for us to identify possible needs and also possible new needs for education and research, and to do this in cooperation with the maritime sector. And this is some of the areas that the Maritime Center also looks into. And as many challenges and problems exist, and that's also, that they will be cross-functional, and we have to like lift them and solve them together in collaboration, it's important to find financing for these research activities, also if they're interdisciplinary. And Maritime DTU is also helping in this area. So we're kind of supporting both the education and the research for the researchers and the maritime field, and the students and the industry to bring them together and support this. And this is both, of course, for ships and offshore and aqua and different areas within the maritime field. Am I close to? Super. Thank you.
Thank you very much, Mette Sanne. Then please welcome Mikael Henriques. You are there. Hello, Mikael. So Mikael Henriques is going to be speaking about freight transport logistics. Please. Thank you.
Good and reliable data is a key source for any kind of good transportation research. Within the freight and logistics sector, we have certainly been lacking good data. So that's what we are really working at now. We are starting asking the whys: where, when, why, what. So we want to find out what's going on within this business. How do we get access to better data? How do we convince our sources, our co-workers, our co-operators that they should deliver data to us in order to plan better, to have better infrastructure, and work together with all the other companies, and certainly also to create value. I've been fiddling with these things for 30 years, and you could say my entire aim goal is that before I retire in 10 years' time from now, I really think we should be a little bit better. So I sincerely hope that's a possibility. And I think we're working ahead. One of our good projects is together with Statistics Denmark, where we are now trying to find out what intermodal statistics are for the Eurostat, and we're trying to develop better explanations on how different modalities work together and how we create exceptional good transport chains. This also goes on for the project funded by the Maritime Fund, where we look into costs, especially for transport chains, in order to see how can we improve the transport chains by knowing more about the cost structure, how costs are being built, and how can you use this knowledge in order to fulfill some of the EU goals regarding the possibility of moving transports from road to sea, as an example. How can we do that by putting together better chains and be more competitive? The same go on for the Novalock project, where we look at costs and data for transport in the Copenhagen municipality, try to find out how to make better transport for freight in Copenhagen, together with all the involved stakeholders. And certainly we also have the Colog project, where we try to have different companies working together on their transports in order to use the capacity which are given by the transport companies, but not always used in the best and most optimal way. Is it possible to use all the capacity if different companies work together via some extremely good databases and certainly use the capacity? And finally, we look at logistics for the future together with the Danish Forwarding Organization, where we try to find out how should tomorrow's forwarder look? What kind of competences should they have? How should they build more innovative and more value-based chains together with the customers? That's one of the few things we do. Thank you.
Thank you, Michael, very much. So the next one is Klaus Kruse, who's going to be introducing us to the Trailer Cat project. Klaus.
Thank you very much. The Trailer Cat is a new generation of a large ro-ro vessel for short sea shipping. If you want to increase or decrease the cost for ro-ro traffic significantly, you have to have bigger units, bigger ferries. And the problem with the traditional ro-ro design is that it is very time-consuming to turn them around in harbor for short routes, and it, of course, influences the cost dramatically. Therefore, we have tried to find another solution, and an answer on this problem is this Trailer Cat design, which are catamaran, and the catamaran is loaded and discharged transversely via a floating wharf. It makes it much faster to turn it around in harbor. As a traditional vessel, you have to take it in and out of aft ramp, and to other decks you have to use internal ramp, which means that the driving in board the vessel is very long. The way you have to drive on board the vessel is very long. The time we have saved in harbor can be used to reduce the speed in sea, and that will result in a fuel consumption. The preliminary calculations of this has indicated that for a route of about 100 nautical miles, we can reduce the cost per unit with 50%, depending on the fuel prices, of course. And what also very interesting, we can reduce the CO2 emission with 70% per unit per trailer. While we're comparing the Trailer Cat LNG powered with the ro-ro vessel in use today on such route. The concept is being developed in cooperation between OSK Shiptech, Bureau Veritas, a classification company, MacGregor, a Swedish cargo handling company, Dansk Brandinstitut, Tetra Pan, which are a transport analyzing company. The same is Transport, a transport analyzing company in US, CBS, and of course DTU. And the project is supported by the Danish Innovation Foundation.
Thank you very much, Klaus. So I'm going to be covering the next one, standing in for Professor Stefan Röpke. So I'm not Stefan, but I'm Alan still. So I will be giving you over the next couple of minutes a few ideas of what is transportation optimization. Well, basically, this is trying to make the most out of available resources, either that be physical resources or maybe labor power. So basically what we are doing is trying to actually solve a puzzle, lay a puzzle, and with the goals of trying to reduce costs of operations and also improve the service level of a given company and reduce the environmental impact. So this science is based on mathematics, mathematical modeling, computer science, and the discipline of operations research. So up here, there are a couple of examples of where this is applied. So basically, we work with all four major modes, you could say, here at DTU, so both the rail, the road, the maritime, and also the airborne transport. So one example of this could be the network design for container liner shipping. So basically finding out exactly what kind of vessels to send to which ports at which time. But also this could be dealing with the timetabling for the railway industry. You do this by modeling these problems mathematically and then solve them using algorithms from computer science and operations research. Yes, thank you. And next up will be smart upgrading by Professor Per Golderman from the Civil Engineering Department.
Yep. Well, I will start talking. Well, you see two beautiful pictures here of a lot of cars and a very heavy truck. And I would say we have nothing whatsoever to do with these things, but we are the supporters. We are the civil engineers. We do the pavement. We try to make it last. We recycle it. And we handle also the bridges. Now, we have a lot of old bridges. They were made with simplified hand calculations with a capacity about this level. Now the trucks get heavier. What happens? Do you take the chance that the bridge can carry, or you accept the traffic infrastructure available shrinks? At the moment, it shrinks a lot. That's a problem. We could take the stupid upgrading, that would be demolish all 12,000 bridges and build some new. Stupid, right? We want to upgrade it smarter, and we are working on 3 legs there. One is the testing. We're going to test 8 bridges to failure, paid by the Road Directorate, real highway bridges, and just to see what they can carry and to set up a concept of proof loading. Proof loading, simplified, is you put the load on that it should carry. If it didn't fail, then obviously it works. It's a little more complicated than that, because you don't want it to collapse, right? But we have done that on a couple of bridges, and they said just one bridge paid for everything the Road Directorate had ever paid us. Then we work with strengthening. Carbon fiber reinforced polymers put on the outside of the bridge, lightweight, strong, and it doesn't corrode. We know this works, always. And then, of course, there's the last thing, because I said simplified hand calculations. You can imagine how much you want to simplify it if you were doing the calculations yourself by hand. It's only after the Great Barrier Link we start to have really good programs to calculate. Of course, we have the problem the models for reinforced concrete are not that good yet. We are working on that. So we can test it. We can string it. We can do better modeling. if you are a bridge owner, which solution would you pick? The cheapest, right? Yeah, road directors have pretty much the same feelings. They don't own 12,000 bridges. They only own about 2,000. Have I got time left over? Shit. I'm in the tent.
Yes, thank you very much, Per, for this very inspiring pitch. So the next one will be the electric vehicle integration research at DTU Electro. Please, Peter Bach.
Okay, thank you very much. Thank you very much. Yeah, so my name is Peter Bach. I'm working as a researcher at the Center for Electric Power and Energy as part of DTU Electrical Engineering. As the center I'm at, we are focused on how we build a Danish power system which is reliable, it's stable, it's economic, and then of course it's based on large amounts of renewable energy. And to kind of obtain that vision, we see the electric vehicle has a special potential. It has some elevating properties that makes it really interesting when we're talking the future power system, when you're talking smart grid, and that is kind of what we want to support from DTU Electro. We believe it so much that we actually founded this electric vehicle laboratory, which is part of our PowerLab DK platform. Okay. So within this center, we have two main focuses. We are focusing on what we call power system integration, which is more or less seeing the electric vehicle as a black box. It's something new which is introduced into the power system. We have to deal with the new demand, and we maybe can even influence this to help out the power system. The second part is the enabling technologies. So here we are looking at the key components in and at the car that connects the battery to the power system outside. So you could say our kind of vision is to become, of course, very good at this, and we have already been, I would say, successful in attracting a few car manufacturers, which is, of course, one of the most interesting partners for us to work with. So this is a great strength, and I hope we can continue building on this. If we look a little bit to the future, I think there's kind of two visions, two things I hope we can achieve within the next few years. We really want to help Transport DTU in electrifying mobility, maybe primarily in the cities. You're going to have buses and others that rely on new infrastructure to provide a lot of power in very short time for opportunity charging. And of course, we also want to continue to be the nation where car manufacturers bring their cars to have them tested as part of the grid and the smart grid in particular. So yeah.
Thank you very much, Peter. So the last one up here is the Carbon Track and Trace project by Lasse Ingbo from DTU Compute.
Yes. Good afternoon, everyone. I'm actually stepping a little bit back from transport, talking about cities, because that's where 70% of the CO2 emissions come from today. And we like living there, true. But if we also look at what do they do, a lot of the political drive there is right now to minimize CO2 emissions, what do? Well, they don't know what they're measuring, because they're not measuring. Most are not, at least. So what we want to do with the Carbon Track and Trace project is to help cities measure their current emission and also their reductions, because many places in the world, what you do is that you downscale from national statistics, which is fine, except for then you kind of rely on European standard emissions from cars, for instance. We know how good they are. We also know that, I mean, if you take a city, how well is that represented by the national level? Say Trondheim, which is one of the two cities in the project, 1 in 7 cars there are EVs. So of course their emissions are lower. But you cannot see that if you downscale all of Norway to the population of Trondheim. Likewise in Vejle, they also have some similar issues. They want to kind of document that they actually did something, but without making local measurements, they don't know what they're doing. So what we are doing is to provide an Internet of Things sensor network to measure emissions of CO2 and other things distributed in the cities, combining that with satellite measurements from the ecosystem and maybe other missions as well, and whatever other information that we can get a hold on, do some statistical modeling, some big data analysis, figure out what is actually the goal there, because what the cities are claiming that they will do is that there is a reporting protocol. It sets a standard for this is what we have to kind of deliver as information, and they don't have it, or they have to do it manually. And I mean, how many of us likes to kind of pull data out of old Excel sheets here and there and pull it together and say, well, now finally I got a number and report that? It would be much nicer if we could just combine all these things automatically, do the analytics, and get running. That's what we want to help out doing. And I don't know if you know, I checked up the other day, in Denmark alone, how large proportion of the CO2 emission actually comes from transport? Roughly 40%. So there's a lot of things to play with there. If you go to Trondheim, where they have a lot of hydropower for their heating, they are about 75% of their CO2 emissions comes from transport. So transport is really one place where we can do something. And I hope we'll help make that change. Thank you.
Thank you very much, Lasse, and thank you for listening into this very fast-paced pitch session of 8 pitches.